Welcome to another restoration video. We have a radio to restore, and as you can see from the logo here, it is a HMV radio. It has got a nice dial and it has got four bands: medium wave, short wave 1, short wave 2 and short wave 3, push button switches, control for bass and treble. Then we have the tuning control here, another HMV logo. That is the magic eye there, and here is the grill cloth in a good condition, we can say, considering the age of this radio. And as you can see from the face of it, the veneer is lost at quite some places. The tuning knob is rotating and the volume knob is also rotating, but the bass and treble are not rotating. They are jammed inside. Some problem there we have to rectify. That is a view of the back of this radio. Well ventilated for passing the heat, and it says model number 5169, AC only. This is an AC only set, assembled in India from Indian and foreign components. And those are the aerial pickup and loudspeaker connectors. So we have taken the chassis out of the cabinet, and now we are going to test if the uh, tubes and other components are okay or not. For that, for the first thing we are going to check is this power transformer. So we're going to check if the power transformer primary and secondary are both continuous or not. So this is the power cord, and it is going through this grommet, and it is terminated on this switch, and from there these two orange wires connects to the primary of the power transformer. So if we check the continuity at these 2 points, then we we can check if the primary is okay or not. So as you can see, when connected to those terminals, we get a resistance of 17 mega ohms. So definitely the primary resistance of a transformer cannot be 17 mega ohms. Either the transformer is open, or there are other, we have to check if other things are wrong or not. When we trace those wires, we come to the point where the wires are connected to the fuse, and then it goes into the power transformer. So when we check this, we find that the fuse are blown. Here it is. The resistance of the fuse is showing 700 ohms. So the fuse is blown, and when we bypass the fuse and connect to these two beyond the fuse, when we connect the terminals beyond the fuse, we get a resistance of 30 ohms. So we hope that the primary of the transformer has a resistance of 30 ohms. So now you are going to check that the power transformer is okay or not. Uh, Here is the power transformer. The white pair is the secondary. This is the on-off switch, but and this is the power cord. So but the on-off switch here is not working. So I have connected, the orange pair is the primary of the power transformer. So I have connected directly on the two wires of the two primary connections of the transformer, and we have hooked it to our bulb current limiter in case there is a short. We can check. As a precautionary measure, we have connected the bulb current limiter, and we will be connecting at the two secondary terminals of the power transformer. You can see it is showing 510 volts or so, like that. So the high voltage secondary of the power transformer is working okay. Now we are checking the filament winding of the power transformer. You can see it is showing 5.9 volts, and it will gradually go to 6.3 volts as the filaments heat up. Since the power transformer is okay, we can go ahead and change the electrolytic capacitor, and then we can power on the unit. So as usual, we are going to change the can capacitor with these individual 47 microfarad at 450 volt capacitors. Here is the terminal of the electrolytic capacitor. We will desolder them and then connect the new capacitors there. So friends, continuing with the restoration process, we have changed all these capacitors, Hunt's capacitors. Uh, this one is an electrolytic 8 microfarad capacitor. So this 8 microfarad capacitor was changed with this 10 microfarad 450 volt capacitor, and those Hunt's capacitor, that zero point 0.1 microfarad is here, zero point 0.1 microfarad replaced with a new VC capacitor. This one is the electrolytic capacitor 50 volts. So this one 50 volt 350 50 micro, I'm sorry, 50 microfarad at 350 volt. So this is the capacitor. So we have changed, this is a two section capacitor. So one of the capacitor is 47, this one, another one is this one. So most of the capacitors are changed, barring this one. This capacitor is 0.006 microfarad, and it is part of the tone control circuitry. But 0.006 microfarad is not available with me right now, so I have left it in the circuit, and here it is. So now we are in a position to switch on the circuit, I mean the radio, and we have connected the speaker. Here is our current limiter, so we are going to switch it on. So as soon as we switch it on, we see that the pilot lamp is glowing. And as you can see, this radio is back to life. That is the broadcast or medium wave band. Now I'm going to switch over to the shortwave band. Not much reception on the shortwave bands. We have also cleaned the tubes. So most of the electrical restoration is complete. Now we will focus on the cabinet of this radio, the wooden cabinet. As you can see, the veneer is coming off at quite some places. Yeah, that is the grill cloth. Not in a very good condition, but that is okay. And that is a view of the speaker, and can be seen that it is kind of okay condition. And here is the cabinet, which has been painted with an uh, Woodfin PU11 glossy paint, glossy clear paint. The back cover is also painted with the same paint. So we have cleaned the chassis and also done the electrical restoration, and we have painted the cabinet, cleaned and painted the cabinet. So most of the work is done. Now we will put the chassis back in the cabinet and then add a new power cable, and that would be the restoration of this radio. The dial glass, it has also been cleaned. So we have installed the chassis back in the cabinet. And we have changed all the screws wherever possible. We have used stainless steel screws. And that is the back cover. are going to give a quick demo of working of this radio. So first we'll put it on the medium wave or broadcast band.
कॉलेज से अंग्रेजी में स्नातक की उपाधि प्राप्त की। सरवर खान सलाम अलैकुम مخلص से चमकनी पैगाम अलैकुम नेपाली सेवाको विख्यात ठेगाना CRI नेपाली از زون‌های مختلف کشور समाचारहरू तथा छेडछाडका सबको करार क्या
televedere panciaku tervitare.
So that was a short demo of working of this radio. The schematic of this radio was not available anywhere, so I reverse engineered and drew the schematic myself. As you can see here, I have drawn it myself from the radio. First there is a power cord, and the power cord goes to the on off switch inside the radio. After that the line and neutral both goes to two fuses, and one of them goes to the voltage selector on the power transformer. The power transformer is a multi-section one. We can select the voltage from 205 to 225 and 245 volts. Voltage adjustment is possible. That's the primary side of the power transformer. On the secondary side, we have a 6.3 volt for the filament and the pilot lamp, and the high voltage center tapped for feeding the full wave rectifier EZ80. This is center tapped. It feeds the EZ80 and full wave rectifier, and the rectifier output is filtered and smoothened with this pi rectifier. Yeah, after this filtration, we have two voltages A and voltage B. The voltage A feeds most of the plate voltage of the valves, and voltage B feeds most of the screen voltages of the valve, screen grid. The connection of the ECH81 is pretty conventional. The first EBF89 is the intermediate frequency and also serves as the detector. This is a second IF transformer. The output of this second IF transformer is filtered and rectified with this resistance capacitance network and the detector of the diode detector of EBF89, and it feeds the preamplifier EBF89, the second EBF89, and also the AGC voltage is taken from here. The AGC voltage feeds the EM81 detector, EM81 magic eye. The preamplifier EBF89 output is fed to the power amplifier, EL84, and in between we have volume control and the tone control circuitry. And the EL84 is connected via the output transformer to a 5 ohm speaker. So that's the circuit of the radio. It is pretty conventional, nothing very complicated or unique about this.